Here's a pre-calc lecture part 2 for 11.2.1, and this is problem number 11-84. We're learning about, I hope that you already know about conjugates. Conjugates of a conjugate of a number is just like it's like the conjugate of a plus bi would just be a minus bi. It's just the two terms, but with the opposite sign, usually with a negative sign. It's just with the opposite sign in between them. And the reason that we like to use those is because when you multiply them out, it's kind of like a difference of squares. The middle term cancels out, like if you FOIL them or put them in the multiplication box. So you'll see when we start doing it. So it says, it said that right there. So they're using this little symbol over the top of the z to say that it's a conjugate of z. So they'll use regular z for the original, and then they'll put z with the little symbol over it for the conjugate. So I don't have enough time to do all of these in the video, so I just worked on letter z. It said, what are the values of z times its conjugate? And these other also, but I didn't do the other two. So I grabbed z, and I grabbed z. So here's z, and here's z's conjugate, and I just multiplied them out because it said z times z's conjugate. So 3 times 3 is 9, 3 times negative 2i is negative 6i, 2i times 3 is 6i, 2i times negative 2i is negative 4i squared, but I squared itself is actually equal to negative 1, so it becomes 9 plus 4. So that's 13. So that's what they wanted. That's the value of z times its conjugate. When you put them right next to each other, it means multiply. And then letter B, so I didn't do all the rest of I didn't do the W's and the V's, but I would do them the same way. Letter B says evaluate, and it has z in this absolute value, and we're to understand that when it's in this absolute value symbols, if it's a complex number, it's asking for the modulus. And remember, the modulus was just like, I don't know, it looked like a hypotenuse on a right triangle if we were in the unit circle. So, not that we're in the unit circle, but that's what it looked like. So I just squared it. Because if this is 3 plus 2i, they just want that length right there. So you could use distance formula. You could, however you want. So I did 3 squared plus 2 squared is c squared, and that's 9 plus 4, and I got c was square root of 13. And then 11-8 for letter C says, how are your answers related? So when I multiplied by the conjugate and letter A, I got 13, but when they asked me for the modulus, I got root 13. So the modulus is just the square root of the, I don't know, product of the conjugates, I suppose. And they wrote it like this. Or they wrote it like this. Z times its conjugate, or this equals the modulus. The square root of z times its conjugate equals the modulus. Okay. Okay, so we got one more problem. This is the last problem for this section, or for this section. 1185 quotients of complex numbers. So complex conjugates can be used to rewrite quotients of complex numbers. For each part below, state the conjugate of the denominator. Then write each quotient in a plus bi form by multiplying the numerator, multiply the numerator and the denominator by the conjugate of the denominator. So I just did it really tiny. Maybe we can zoom in and you'll be able to see it. Okay, so I just only did this one. So I said the conjugate was 3 minus 2i, the conjugate of the denominator. I multiplied across the top. 5 times 3 is 15. 5 times negative 2i is negative 10i. Multiply across the bottom. Well, I know we're going to have a cancellation, and it's going to end up being 3 squared plus 2 squared. If you still want to multiply it out, it's 3 times 3 is 9. 3 times negative 2i is negative 6i, but 3 times positive 2i gives you positive 6i. They cancel out, and 2i times negative 2i is negative 4i squared, but we already went over that. It's going to end up being a negative times a negative. We're going to have a positive. So I get this, and then I can say, well, 9 plus 4, that's 13. And so now I'm here, and then I can just rewrite it as two separate fractions, the real part and the imaginary part, the complex part. So because this is a plus bi, so the imaginary part always goes second in the real part, and you have to separate them or else it's not in a plus bi form. So that's all I have for now.